Hello, good morning students. How are you today? I hope that you are doing well in this new normal classroom. I'm Sir Joel Mahilong from Santa Ana National High School, your teacher for today. In this video, we will be discussing illustrating rational algebraic expression. So these are our objectives. After watching this video, you're expected to define rational algebraic expression, identify rational algebraic expressions, evaluate rational algebraic expressions, relate rational algebraic expression in real-life situation, and simplify rational algebraic expression. How can we apply this lesson in real life? The speed of the cars, which is kilometer per hour, applies rational algebraic expression. The work that a person does applies also rational algebraic expression. Don't you know that in getting the height of this tree without actually climbing it, we can make use of the shadow of a person, and still it is applying rational algebraic expression. The rating in your particular assessment also applies rational algebraic expression. Then what is rational algebraic expression? So a rational algebraic expression is an expression that can be written in the form of P over Q, where P and Q are polynomials and Q must not be equal to 0, or the denominator of a fraction must not be equal to 0. So in other words, the rational algebraic expression is an expression whose numerator and denominators are polynomials. In our module in the previous activity, the expression formed in items 1, 2, and 3 are rational algebraic expression because the numerator and the denominators are polynomials. But again, let us remember and let us recall, how are we going to determine that the given algebraic expression is a polynomial? So polynomial is a mathematical expression of one or more algebraic terms, each of which consists of a constant multiplied by one or more variables raised to a positive whole number or exponent. So the exponent of the variable must be positive, at the same time a whole number exponent. So these are the examples of rational algebraic expression. So first, the expression 6 over x minus 3. Second, y squared minus 1 all over y cubed minus 3. Third, 18n plus 1 all over n squared plus n minus 2. In contrary, these are not examples of rational algebraic expression. 3x minus square root of y all over 5 times square root of x. 2x raised to negative 2 minus 3 all over x plus 6. Thirdly, we have 3 minus z raised to the power of positive 3 all over z raised to negative 2 plus 5. So as you can see, these expressions here are no longer examples of rational algebraic expression because there are expressions in the numerator or denominator which is not raised to a positive whole number exponent. So in this case, we have a negative exponent. So we have also an expression here. This is in terms of radical. So when do we say that an expression becomes radical? So this could be your lesson in your grade 9. So the expression becomes radical if the exponent of a variable is a fraction. So these are the tips useful in checking whether the expression given is a rational algebraic expression. So first, you have to check that the expression must be in a fraction form. There must be numerator and denominator. Secondly, the expression must have in its numerator and denominator a constant, or it can be a variable, or combination of both constant and variable that are polynomial expressions. Lastly, the expression must not have a negative exponent, like this one, must not have a radical sign, like this one, or a fraction exponent in the variables in both numerator and denominator. So that is why these examples of expression are considered not an algebraic expressions. Now let us remember that a rational algebraic expression is a fraction containing polynomials in both numerator and denominator, provided that the denominator must not be equal to 0. So what will happen to the denominator becomes 0? So the denominator cannot be 0 because division of 0 is undefined or meaningless. In a rational algebraic expression, we need to pay attention to what value of the variables that will make the denominator equal to 0. And this is called the excluded values of the expression. And how do we determine the excluded values of a given rational algebraic expression? So these are the steps in determining the excluded values of a given algebraic expression. So all you have to do is just to pay attention in the denominator. So what is the value of the variable that will make the denominator 0? So step 1, we're going to let the expression, the denominator, be equal to 0. Secondly, we're going to solve the equation to determine the value or the values of the variable. So let's have an example number 1. So identify the value of the x that will make the expression 6 over x minus 3 undefined. So first, you're going to let the denominator be equal to 0. So all you have to do, so you just copy the denominator and equate this one to 0. So we have now the equation, which is x minus 3 equal to 0. So solve the equation to determine the values of the variable. So our task now is to solve for the value of the variable, or to solve for the value of x that will make this equation in step number 1 be equal to 0. So this is our given equation. So we are going to apply our skills in solving a linear equation in one variable. So we have to recall the addition property of equality. So what are we going to do is we're going to isolate the variable at the left side of the equation. So negative 3 must be removed or become 0. So what are we going to do? We will add the additive inverse of negative 3 such that if you add negative 3 by positive 3, it will become 0. So since we added positive 3 here, by virtue of this property, we must add also 3 to the other side. So take note, what you do in the left side of the equation must be done to the right side of the equation to balance the equality. So negative 3 plus 3 becomes 0. So equals x now plus 0. And 0 plus 3 is equal to 3. After which, x plus 0 is equal to x. So therefore, we just copy positive 3. So the value of x is equal to negative 3. And how do we know that this is correct? So again, let's go back to our given algebraic expression, and we're going to substitute the value of x. So from the given expression, 6 over x minus 3, so all we have to do is just substitute x by the solved value of x, which is 3. So this is now 6 over 3 minus 3. Then 6 over, so we just copy the numerator. So 3 minus 3 is equal to 0. And take note, once again, that dividing 0 is meaningless, or we call it undefined. So since division of any number by 0 is undefined, so therefore, 3 is the excluded value of the rational algebraic expression 6 all over x minus 3. So let's have another example. Identify the value or values of n that will make the expression 18n plus 1 all over n squared plus n minus 2 undefined. So first, we're going to equate this expression. This is the denominator equal to 0. So solve for x. So by factoring, we can say that the factor of this expression, n squared plus n minus 2 is equal to 0, is n, which is the factor of n squared, and the factor of the first term of these factors are the factor of n squared, or factors of n squared. So what is the factor of negative 2, such that if we add the factors, the sum is the coefficient of the middle term, which is the coefficient of n, which is positive 1. So since this is negative, so the factor is 1 positive and 1 negative. So therefore, positive 2 and negative 1. Because if we add positive 2 and negative 1, so we are going to subtract 2 and 1, so that is 1, and the sign is positive. So that is the coefficient of the middle term. So therefore, we can say that this is the correct factor of the n squared plus n minus 2. So equals to 0. So according to the zero product property, that if the product of the two factors is equal to 0, we can equate its factor to 0. So therefore, n plus 2 equate to 0 and n minus 1 equate to 0. And solve for n. So you just transpose the positive 2 to the other side, or applying the addition property of equality. So this is negative 2 and this is n transposed to the other side becomes negative 1. So take note, the concept of transposing one's quantity to the other side of the equation is not a property. The property behind is addition property of equality. The transpose is just a shortcut. But take note, when we transpose, like this example, then the positive 2 is at the left side of the equality. If the positive 2 will be transposed, will be transferred to the right side of the equation, its sign will change. From positive, it will become negative. Same goes with here. It is negative and it becomes positive here. So if n is equal to negative 2, so the expression would be, the given expression, so all we have to do is just substitute the value of n, which is negative 2. So n here, instead of writing n, change it to negative 2, and n squared becomes negative 2, and negative 2 minus 2. And simplify. So 18 times negative 2 is negative 36, then plus 1. Then all over negative 2 squared, negative 2 quantity squared is negative 2 times negative 2. That would be positive 4. Then positive times negative becomes negative 2, and we just copy negative 2. So further simplification, negative 36 plus 1 is negative 35. Then 4 minus 2 is negative 2. Then minus 2 is 0. So that makes the expression undefined. So what if we will try if n is equal to 1? So same is true. We're going to substitute the value of n, which is 1, from the given expression. And we just simplify. So 18 times 1 is 18. Then copy 1. Then 1 squared is 1. Then copy 1 minus 2. Then 18 plus 1 is 19. All over. 1 plus 1 is 2. Minus 2 equals 0. So that makes it undefined. So since the division of any number is 0 still undefined, therefore we can say that in this given expression, the excluded value is negative 2 and positive 1. Because these values will make the expression undefined, will make the denominator equal to 0. So you can verify that if the excluded value is substituted in the expression, it always ends up to division by 0. So you have to bear in mind also that there are some values that will make the expression defined, meaning it's not equal to 0. How are you going to inspect it? That the value of the fraction will rational algebraic expression undefined. So this process is called evaluating expression. So let's have an example. Y squared minus 1 all over y cubed over 3. So we're asked to evaluate this one given that y is equal to positive 2. So what we're going to do, we're just going to replace y by the given value, which is 2. And we are going to simplify. So from the given expression, instead of writing y, substitute it by 2. So magiging 2 squared minus 1 all over 2 cubed over 2 cubed minus 3. Then simplify the numerator and the denominator. So the numerator for 2 squared is 4, copy negative 1, and 2 cubed is 8. So take note, 2 cubed is 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. So therefore 2 cubed is 8 minus 3. So 4 minus 1 is 3 and 8 minus 3 is 5. So in this case, if y is equal to 2, this expression is no longer undefined. So in this case, because this is not, the denominator is not 0, we can say that this is defined at y is equal to positive 2. And this is evaluating expression. Thus, we can say that when y is equal to 2, the expression y squared minus 1 all over y cubed minus 3 is equal to 3 over 5. Moving forward, let's have another example. Evaluate the expression 5x squared plus 6x minus 11 all over x plus 1 when x is equal to still positive 2. So again, replace the variable x there from the given by 2. So instead of writing x, substitute by 2. Instead of writing x, substitute it by 2. Minus 11, and denominator x 2 plus 1. Simplify. So 2 squared, so we will follow the PEMDAS rule. So simplify first with the exponent. So 2 squared is 4, just copy 5. Then multiply 6 times 2 becomes 12, copy negative 11. Then 2 plus 1. Further simplification. So 5 times 4 is 20. Then plus 12 is 22. Then minus 11, 32 rather. Then minus 11 is 21. And 2 plus 1 is 3. So 21 divided by 3, since this fraction can be simplified, so it becomes 7. Thus, when x is equal to 2, the expression 5x squared plus 6x minus 11 all over x plus 1 is equal to 7. So what are the real-life application of algebraic expression? So let's have an example that Vanessa can finish writing the module in X hours, while his brother Ryan can finish writing the same module in Y hours. Write an expression that will illustrate the rate of work to finish writing the module. So this can be illustrated using a table. So in the second column, these are the time in terms of hour, and the third column rather, these are part of the work over or per hour. So in the second row would be for Vanessa. So take note, Vanessa can finish the job. The time that is she will be spending in working the module is X hours. So we will substitute X here for the time. So therefore, in one job, he can finish that one in 1 over X. So this is the part of the work of Vanessa. How about Ryan? So Ryan, take note, he can finish writing the same module in Y hours. So the time that he will be spending in writing this module is Y. So the part of the work of Ryan is 1 over Y. So you can represent 1 over X for Vanessa to accomplish a work per hour, since she can finish writing the module alone in X hours. On the other hand, you can represent 1 over Y for Ryan to accomplish a work per hour, since he can finish writing one module alone in Y hours. So let's have another example of how are we going to apply the concept of rational algebraic expression in real life. Suppose the area of a rectangle is x squared minus 121 square units, while its width measures x plus 11 units. Illustrate a rational algebraic expression in finding the length of the rectangle. So in this given problem, the area of the rectangle is given, so thus the width is also given. So what is asked is the length of the rectangle. So take note, in finding the area of the rectangle, given the length and the width, the formula would be area is equal to length times width. So if we are going to derive, since what we are looking here is the formula in finding the length, so this is given and this is given, so we want to isolate L to the right side of the equation. So what are we going to do is we're going to divide both sides by W, or the width. So divide W here for the area, divide also W here for the length. So take note that in the right side, we're dividing W. In the left side, we have to divide W also. So W divided by W, ang maiwan ngayon is just the length. So therefore, the length of the rectangle will be obtained by dividing the area by its width. So since the area is equal to x squared minus 121, we just substitute. And the width is x plus 11, we also substitute. So therefore, this expression represents the length of the rectangle given the area, which is x squared minus 121, and its width, which is x plus Simplifying rational algebraic expression. How do we know that a fraction or rational algebraic expression is simplified or in the lowest term? Fraction is or rational algebraic expression is simplified if and only if there is no common factor between the numerator and the denominator. How are we going to simplify rational algebraic expression or a fraction? So first, we're going to factor the numerator and the denominator completely. Secondly, we are going to cancel out the common factors of the numerator and denominator if there is or are any. Thirdly, we're going to multiply the remaining factors. So, to do such, let's have example number 1. Simplify the expression 15 over 20. So first, we're going to factor the numerator and the denominator completely. So our numerator is 15, denominator is 20. The prime factors of 15 is 3 times 5. The prime factors of 20 is 2 times 2 times 5. So from the given prime factors, let's take a look with the common factors between the numerator and the denominator. So in this case, that is 5. So we're going to cancel that out because their quotient, if we divide them, that is equal to 1. So what is left now is 3 all over 2 times 2. So you just multiply the remaining factors. So 3 times 1 is 3. Then 2 times 2 times 1, and that is 4. So therefore, the simplest form of 15 over 20 is 3 over 4. Example number 2. 28x to the power of 3 all over 7x to the power of 4. So 28, the prime factor of 28 is 2 times 2 times 7. So x to the power of 3, so we are going to multiply 3x by itself. So 7 is already prime, we just copy. Then factor of x to the power of 4, so there are 4 x's. 1, 2, 3, 4. So notice the common factors. So in the numerator and denominator, with respect to the constant, the common is 7. So we will cancel them because their quotient is equal to 1. So the first x and the other x. Next x and the next x. Then the last x in the numerator and the third x in the denominator. So what is left now? So take note, those quantities that we're going to cancel out, that would be equal to 1. So 2 times 2 times 1 is equal to 4. Then 1 times 1 times 1 times x, that is equal to x. So therefore, the simplest form of 28x to the power of 3 all over 7x to the power of 4 is equal to 4 over x. Now let's have example number 3. Simplify the expression 3x minus 12 all over 5x minus 20. So we will factor the numerator and denominator completely. So in this case, our numerator and denominator are both polynomials. So factor the numerator, we will do it by common monomial factoring. The common monomial factoring between the 3x and 12 is 3. So to obtain the terms inside the quantity, we just divide each term with a common monomial factor of 3x and 12. So 3x divided by 3, that would be x. Negative 12 divided by 3, that would be negative 4. We will do the same at the denominator. So our common monomial factor is 5. So 5x divided by 5, that would be x. Negative 20 divided by 5 is negative 4. So notice the x minus 4 and x minus 4 are common factors, so we will cancel them out. So what is left now is 3 over 5. So this is now the lowest term of this given expression. Next example. Simplify the expression 3x squared plus 9x all over x squared plus 2x minus 3. So in this case, our numerator will be factored using common monomial factoring, and our denominator will be factored using factoring general trinomial. So the common monomial factor of 3x squared and 9x is 3x. How do we get 3x? So 3 is the common monomial factor of 3 and 9, or the GCF of 3 and 9. The common monomial factor of x squared and x, of the x with the lowest exponent, the variable with the lowest exponent. So we take x. So 3x squared divided by 3x, so that would be x. Then 9x divided by 3x, so that would be 3. So to factor the denominator, the first term of the binomial factors would be the factor of our first term in the trinomial. So our first term is x squared. So the x squared, the factor of x squared must be x times x. So if we will multiply x times x, or this binomial to this binomial, using the FOIL method, we will obtain the x squared. Now, how do we get the constant that we are going to use to have as the binomial factor here and here? So these are the possible factors of the constant, which is -3. Now, how do we know that these are the factors that we are going to use? So we will factor the -3 such that if we add the factors, their sum must be equal to the coefficient of the middle term, which is +2. Since this is -3, so this is -3, so what are the factors of -3 such that if you add the factors, the sum is +2? So since this is negative, one of its factors must be positive, the other must be negative. So therefore, our 3 is positive and the 1 is negative. So we will try to examine if there is a common factor between the numerator and denominator. So in this case, that is x plus 3. Cancel them out. So what is left now is just 3x and x minus 1. So this is now the lowest term of this given expression. Note, we can only cancel common factor but not common term. So in this case, in example number 4, we cannot cancel x and x because x here is a factor, x in the denominator is a term. So you cannot cancel x in the denominator and x in the numerator. Same is true with here. So you cannot cancel automatically the x because x here is part of the term. So again, you can only cancel common factor, but you cannot cancel common terms. So how do we know that that is factor? It must be placed in a quantity or it must be placed in a dot, which means they are being multiplied. So example number 5. Simplify the expression x squared minus 25 all over x squared minus 3x minus 10. So our numerator is a difference of 2 squares because the first term is a perfect square, the second term is also a perfect square. So to factor x squared, we just get the square root of x squared. So that would be x and x. So next, the constant would be the square root of 25. So what's the square root of 25? So that is 5. So since this is different of 2 squares, the first term must be negative, the second term must be positive, or it can be used interchangeably. The positive here and the negative on the other factor, so long as both of them have a different operation. If you multiply them, the answer would be x squared minus 25. In the denominator, again, this is factoring general trinomial. So x and x are the factor of x squared. So we will try to find factors of -10, which is the constant, such that if you add the factors, the sum is -3. So what are the factors of -10? So you can have it 10 times 1 or 2 times 5. So in this case, we will consider 5 and 2. So since this is negative, one of the factors 5 and 2 must be negative, the other should be positive. This is -10 and this is -3. So the -5 must carry the sign. Because if we add -5 and +2, subtract since they are unlike signs. So 5 minus 2 is 3 and the sign is negative and that is -3, the coefficient of the middle term. So we factor this out completely already. So the common factors between the numerator and denominator is x minus 5. We will cancel that out. So what is left is the expression x plus 5 all over x plus 2. And this is the lowest term. So once again, you cannot cancel the x because they are common terms, not common factors. Example number 4. simplify the expression m cubed minus m all over m cubed plus 1. So in this kind of problem, we will be trying to integrate all different forms of factoring. So as you can see, the first term is m cubed and the second term has an m. So this is not difference of two squares. But as you can see, the first term and the second term has a common monomial factor which is m. So if we factor out the term using the common monomial factor, so what happens now is we will remove the common monomial factor which is m, the common monomial factor of m cubed and m, and that is m. So m cubed divided by m, that would be m squared. The negative m divided by m, so that would be negative 1. So this is now the factor of the numerator. Now our denominator is a sum of two cubes because m cubed is a perfect cube and 1 also is another perfect cube. So to factor, if we may recall lesson natin sa factoring, to factor the sum of two cubes, we just get the cube root of the first term. So the cube root of m cubed is m. Because m times m times m, that would be m cubed. So m times m is m squared. Then m squared times m, so that would be m cubed. What is the cube root of 1? So that is positive 1 also. Because 1 times 1 times 1 is 1. Now, how do we obtain this product? So this is special cases of special product in which the first term of the trinomial here is just the square of the first term of the binomial. So if you square m, this is m squared, the first term of the binomial. Now, how do we obtain the middle term? So if you multiply m and 1, that is m. You just get the additive inverse. If that is positive m, change it to negative m. And lastly, the constant or the last term of the trinomial is the square of the second term of the binomial. And that is square of 1 and that is 1. Now notice that our numerator m squared minus 1 can be factored out because as you notice, this is difference of two squares. So to factor that, what are we going to do? We will follow the factoring difference of two squares. So we just copy the m. So m squared, its square root is m. Then square root of 1 is 1. So m plus 1 is the first factor. We just copy these terms, but we will change the operation. If this is positive, this must be negative. If you write negative first here, the next factor must be positive. Notice that our numerator and denominator is factored completely. Now we will take a look with the common monomial factor or common factors. So m plus 1 in the numerator and m plus 1 in the denominator will be cancelled out. So what is left now is m, copy, then m minus 1, then copy m squared minus m plus 1 and, in our denominator. So that would be the simplest form of this given expression. So I want to say thank you to everyone for your time and for your enthusiasm to continue to learn despite of this pandemic. So I hope that in your succeeding lessons, you will have the same motivation and passion for the quest of learning. So I will leave you with this saying that says, according to Nelson Mandela, education is the most powerful tool or weapon to change the world. Okay, thank you everyone. Have a good day. Bye.